To review quickly, if the a value is 1 for our factors, we are always going to create our two parentheses for factoring right away. And the first number is always going to be 1x because we are trying to create the factor of 1 out front of the parentheses. In order to create the middle number, we look at the factors of our c value, which are 1 times 2, are the only possible factors. Because this number here is a negative, it means we either have to be adding two positives or adding two negatives. In this case, we are going to do -1 plus -2, because that's equal to -3, which is the middle term that we want. We can then do a -1 and a -2 in either spot, because it doesn't matter for these types of problems, and we can simply solve from here, getting our values of +1 or +2, which was a solution to our equation. Okay, now this graph does not match this problem, but we are always looking for these x-intercepts, or we call them zeros here. Okay, and once again, this graph does not match this problem. I just wanted to look at examples of zeros. Okay, so let's get into some harder examples where the a value is no longer 1. And since the a value is no longer 1, when we create our parentheses, we need to look at the factors of both this number and our final c value as well. So the factors of 2 are only 1 times 2. The factors of 12, though, are 1 times 12, 2 times 6, and 3 times 4. And I need to create the middle number of +11 by using these pairs of factors. I notice that the final number here of 12 is positive, so I'm going to be adding two numbers together to get +11. What I could do is I can pick this pair of factors, and I can pick any pair of factors here on the edge. If I did this one, I could do 2 here times 1 here, and I always want to write this number first, this number second, plus 1 times 12. That would give me 2 plus 12, which is 14, does not equal 11, so that means we are incorrect and need to pick a different pair of factors. Now, this pair has to be chosen, but I know that if I pick this pair of factors, I can do 2 times 4, which is 8, plus 1 times 3, which is 3, and 8 plus 3 gives me the 11 that I'm looking for. So now that I have found my pair of factors, I have to put them into the correct spots in my parentheses. Okay, so these are the factors that go in our first and third spot, here and here. And it's 1x and 2x, which gives us the 2x squared term out front. The third and fourth column that are open here are filled by this 3 and 4. And this is the mistake that everybody's going to make, because they're going to put these in the wrong spot. I know that the 4 must be multiplied times a 2. The 2 is right here. If I put the 4 here, it will never be multiplied times the 2. So the 4 has to come in the front. And because these are all positive numbers, it'll be +4. The final number that's left over is a +3, which will go right there. Now, with all these problems, you want to check your answers. But before we check it, we want to solve by setting each of these equal to 0. This one will become x equals -4 as one of our solutions. or 2x equals negative 3. So x equals negative 3/2, which is the same as negative 1.5. So there are our two solutions. And now to check our answer, we can use our trusty friend Desmos, which is right here. And I've graphed this equation. I'm going to zoom out a little bit here because if you notice oops, there we go. The vertex is down here, which is a crazy decimal. But we only care about the zeros. One of my zeros is right here at negative 4, which is what we got. The other zero is at negative 1.5, which you can write as a fraction or a decimal. So let's do one final example. So we have 10x squared minus 29x minus 21 equals 0. Just like always, we're going to put our two sets of parentheses equal to 0. And we're going to look at the factors of our a value and our c value. Now I notice this is a negative 21, so we are going to be subtracting when we're solving our problem. So our factors of 10 are 1 times 10 and 2 times 5. And the factors of 21, 1 times 21 and 3 times 7. I do not care about which order they are, so I can write them just like this. And now I need to find a pair of factors here times a pair of factors over here that can create negative 29 with subtraction. So I'm going to do my bottom pair of factors here and my bottom pair of factors here, because I'm going to do 2 times 3 minus 5 times 7. 6 minus 35 is negative 29. So we have identified the correct pair of factors. And now let's get them into the right spots in our parentheses. We're trying to create 10x squared here. So we're going to do 2x and 5x. Okay, this is the point I would hope everybody can get to in every problem, because 2 times 5 is 10, x times x is x squared. Now this is the hard part, and the one that you will definitely mess up at least a few times. Okay, so I want to do 3 times this 2. So the 2 is right here. So I cannot put the 3 here because it will never be multiplied times the 2 because of the distributive property. So the positive 3 has to go out here behind. That leaves only one spot remaining. And this has to be a negative 7 here. So to check, I will get 10x squared plus 6x minus 35x minus 21 equals 0. So I get 10x squared minus 29x minus 21, and we got our answer correct. From here, we then have to just set each of these equal to 0 because of the zero product property. And we can solve from here. And I'm actually going to jump over this step to make sure we keep the video a little short for you. Because honestly, this is a hard concept, and we could go over 100 examples here, and we'd still make a few small mistakes. Now, this is a hard concept. I'll tell you that right now. The key, though, is that if you are somebody who is good at guessing and checking, you are going to eventually get the right answer inside these parentheses. Use the strategy over here on the left, and then try to get these first two numbers done. And then you really only have a few options for those final two numbers. And a lot of times, if you just power through, give a few solid guesses and check, you will eventually get the right set of factors in the right places. But As always, if you have any questions, please let me know.